Hello everyone, this is lecture 2 where we're going to be talking about logarithms. So again, still kind of review. But anyways, for this first question, we want to just expand this expression. Okay? So I'm not going to go over the rules of logarithms because you did that in high school. So basically, we know that x squared is being multiplied by the square root of x squared plus 2. So we can split that up, right? So we can say ln of x squared plus ln of the square root of x squared plus 2, right? And then we're dividing all of that by 3x plus 1. So you know that when you're dividing, that can be written as subtraction, right? Using the rule of logs. Again, you should remember this from high school, but if you don't, just watch a quick video on the properties of logarithms. But that's not the point of this video. Okay. Next question is express ln of a plus 1 over 2 ln b as a single logarithm. Okay. So if we rewrite this out, apologies for that. Well, using the properties of logs, right? We know that this 1 over 2 can be brought up here as an exponent. So this can be written as that, right? But then that's the same thing as saying the square root of b, right? And then using properties of logs again, right? This can be written as log of a multiplied by the square root of b, okay? So that's how you express it as a single logarithm. So for logs, that's pretty much it. Again, you're not really going to be learning anything new about logs, so perhaps we can go over a few properties that would be helpful. So you should know that ln of 1 is equal to 0, which in this, sorry, I'll write it like that. And then technically, ln of 1 being equal to 0 can be rewritten as this, Euler's number, whatever it's called. Oh, and here's something important to know. If you have x to the power of some exponent, that's equal to Euler's number to the power of r ln of x, okay? And yeah, that's pretty much it for logs. I mean, well, okay, let's do 2 more examples and then we'll be done. But yeah, you're not going to cover, well, you will use logs a lot, but you're not going to learn too much more about logs, okay? So solve ln of x equals 5 for x, okay? So again, we know that ln of a being equal to b can be rewritten as Euler's number to the power of b being equal to a, right? So then we literally just plug in the expression we're given, right? And this can be rewritten as, I'm just going to say e to the power of 5 being equal to x, right? And that's what x is equal to. Okay. And then last example, we want to solve x given this equation. Okay. So what you can do here is you can take the ln of both sides. Okay. And the reason why you want to do that is because we know that ln of e to some exponent is just equal to the exponent. That's a property, but it's quick and easy to explain. And that's because we know that the base of the natural logarithm is just e, right? So then if the argument, which is this, is e, we know that the answer is equal to 1, right? Because this is saying, to what power is this bottom number equal to this number? And the answer is 1, right? So then that's why the answer would just be the exponent. Okay. And then you can just isolate for x here, which is pretty easy. Okay. And then x is equal to, you could divide the whole thing by 3, but typically in university, you want to write it like this to keep it neater. But both answers should be fine. So yeah, that's logs. Okay.